All right, let's show how to set up a simple linear programming problem in Excel and then set it up in Solver and have Solver run it. So here's our word problem. And you can take a sec to read that, maybe pause the video and read it. All right, so what I'm going to do is reserve some cells for what will be my decision variables. And I'm just going to color those cells. Here I've colored them green because I want a color that links to the word decision variable in my mind. Very few colors start with D. Are there any colors that start with V? Well, you might think violet, but I need that for something later. So I'm going to go with verde or green. So Excel doesn't care what color they are, but it really helps. I know this is going to be a cheesy coloring scheme, but it actually does help. And I'm going to say right above each variable, what's the name of that variable? So the number of type A housing units to build or apartments to build, and the number of type B. And then I don't have to put numbers there, but you could if you want to. Solver will fill them in later. And then I'm going to say what's my objective. I want to, in this case, maximize the number of people housed. And that's 3 per type A and 2 per type B. So I'm going to say take however many type A things you're making and multiply by 3 per house per apartment. Take however many type B things you're making and multiply by 2 people per apartment. So what Excel function will let me do this times that plus this times that? You guessed it, sum product. And I already have it filled in here. Don't worry, you'll get to type it in yourself on one of the later sheets or lots of the later sheets. So I'm saying sum product of these cells times those cells. You can see I have some dollar signs here. That doesn't mean dollars like currency, like pounds and yen and euros and everything. It means absolute reference in Excel, and I'll show you why in just a sec. So I'm saying take these times those. I can try out my formula just to make sure it's good. Like if I build 0 of each type, I get 0 people housed, right? If I build 10 of this type, then I have 10 times 3 plus 0 times 2, so I get 30. If I build, let's say, 100 of that type, I get 0 times 3 plus 100 times 2, so I get 200. So you don't have to do this playing around. You can even leave the cells blank, but I just wanted to show you how it works and show one way of kind of making sure your own work works. This is our objective function, so I want to color it a color that reminds me of the word objective, and orange is the obvious color there. The big downside to the system is that the most common kind of color blindness is red-green color blindness, and orange is pretty close to red. So I've got some descriptive words on the spreadsheet here in case anyone is having trouble seeing the colors, or if you print it in black and white, for example. So that's our objective function. And I've got the word maximize written on the spreadsheet here, and we'll see later about maximizing versus minimizing. And then how about my constraints? Well, we know that each apartment of type A takes 2 units of finishing labor, and each apartment of type B takes 1 unit of finishing labor. So the total amount of finishing labor we use is going to be type A times this plus type B times that, and that's a sum product again, a big surprise. So I've got that filled in here, but if I didn't, what I could do is, let me delete that. I could even copy what I have here, and I'm going to paste it here. I right-clicked, and I'm going to paste the formula so I don't accidentally copy the yellow color or the orange color. And that way, this formula was referring to these 2 cells. When I paste it down here, it'll refer to the 2 cells next to it, but because I use that $ locking up here, that reference won't move down a few rows. Once I have it pasted here, I can autofill there. Of course, I already had it there. And again, I can say, well, what if I built 10 of these and 0 of those? Did you notice that even when I don't have a 0 there, sum product still treats it as a 0? So that's interesting to know. So if I build 10 of these, then I'll use 20 units of finishing labor. I use 10 of carpentry labor, etc. So that's another way of checking. But I can go back to that. So again, with the color code, this is the left-hand side of the inequalities. So I wanted a color that starts with L, so I thought of lavender or lilac. I have trouble telling the difference. And this is the right-hand side of the inequalities. Red is the obvious choice there, but red often means, whoa, something's dangerous, stop. So I went with rose, still starts with R. And that's kind of why I didn't want violet, because it would get, for the decision variables, because it would get confused with those. All right, so we've got our problem set up, and now we need to run solver. And we'll do that in the next video.